Okay, this video is about the dividing like bases, which is one of the exponent laws. When you have two like bases being divided like this, or even with a division symbol, there's going to be a law of divide this. Now, x to the fifth is the same as x times x times x times x times x. X times itself 5 times. X to the third, x, x, x. Now, you'll remember when going back to simplifying fractions that if you had a common factor between the numerator and denominator, that they would cancel. So these three x's would cancel, leaving you with x times x, which is x squared. Now, if you think about this, there were 5 x's. We took away the 3 from the bottom, and we got an exponent of 2. The exponent law says that when you're dividing like bases, and they must be like bases, these are both x, that you can subtract the exponents to get the new exponent on your base. Let's take a look at some examples. All right, here we have x to the 8th over x to the 3rd. Now, I could do that whole x times x times x times x and all that, but that's going to take a lot of time. I don't want to do all that. So instead, I'm going to work with the law that says I can take the exponents and subtract them. X to the 8 minus 3 becomes x to the 5th power, and that is the simplified version of that expression. Here we have a to the 5th divided by 2, which is going to become a to the 5th minus 2, which is going to give me a to the 3rd power. Top exponent minus the bottom will give you the final answer. Top minus bottom gives you your exponent on the final answer there. The base stays the same. Now, I know some people, when they see something like 3 to the 5th, times 3 to the 9th, they think that this has to be 9 to the 14th power because they do add those exponents here, and they think they have to multiply the bases. By adding the exponents, you are multiplying. This would not be the right answer. This would work out to be 3 to the 14th, not 9 to the 14th. The base stays the same. It's only the exponents that get added. What about when you have coefficients like we have here? Well, this first one is the same as saying 8 halves times x to the 9 over x to the 5th power. Remember, when you have two fractions being multiplied, numerator times numerator gives you the numerator. Denominator times denominator will give you the denominator. So this is the same thing as this. When you look at it this way, though, you can see that you're going to simplify the 8 over 2, which 8 divided by 2 will give you a 4. This part, you're going to subtract the exponents, which is going to give you 4x to the 9 minus 5, which results in 4x to the 4th power. And that would be your final answer on that one. And I can't seem to draw a 4. There we go. And the next one here, we have 3 over 12 times x to the 10th over x squared. 3/12 were reduced to 1 over 4 because there's both divisible by 3. Then the other part would become x to the 10th minus 2. That would be the subtracting of exponents. Then when you simplify, this would end up being 1/4 x to the 8th power, which you can write as x to the 8th over 4, because 1/4 times x to the 8th is the same as x to the 8th over 4. So these are the two answers here. Okay, now you do. Try these 3 problems. Pause the video, give them a try. Welcome back. On this one, this would become b to the 7 minus 2, which is going to give you b, will give you b to the 5th power. This would be y to the 27 minus 27, which is going to give you y to the 0, which is not completely simplified because anything to the 0 power would be 1. That would be your final answer on question 2. All right, question 3. We have the 6/9 and the x to 11 over x to the 5th power. The 6/9 will reduce to 2/3. The x to 11 is going to be x to the 11 minus 5, which is going to give you 2x to the 6th over 3. Taking the result of the x to the 11 minus 5, putting it on the top part of the fraction, because the bottom here is a 1. 3 times 1 will give you 3. 2 times this will give you the 2x to the 6th. Okay, here are some mixed dividing and multiplying problems where you may have some dividing of like bases and some multiplying of like bases mixed together. My first step would be looking at this part here when I see I've got dividing of like bases, so I subtract the exponents. When I subtract them, I'm going to end up with x to the 4th power, and I'd be multiplying that by x to the 4th power. Since they're multiplying, we add the exponents, which becomes 4 plus 4, which is 8. And that's my final answer on the first one there. On the second one here, I've got some multiplying going on inside the parentheses on top of the fraction here. So I have to take care of this first. When I multiply the like bases, I need to add these exponents. 9 plus 4 is going to give me 13. So I have x to the 13 over x, which will be multiplied by x to the negative 3. This is understood to be a 1 here, even though there is no exponent, there's understood to be a 1. 13 minus 1 is going to be 12. So that's going to give me x to the 12 times x to the negative 3. If I can write the negative 3 in there, squeezing it in. All right. From there, I would add those exponents, so that's going to give me 12 plus negative 3 is going to give me x to the 9th power as the final answer there. This is just an equal sign. Let's not get rid of that. Okay. X to the 9th power is the final answer there. All right, here we have some mixed division and power to a power problems. All right, here we have, on the first one here, we have power to the power within the fraction. So this is going to become y to the 3 times 7 over y to the 10th, which is going to give me y to the 21 over y to the 10th. Subtract those exponents, and I get y to the 11th as my final answer. Here we have the exponent on the outside, and we can either distribute to both the top and the bottom, meaning we do the power to the power with this and power to the power with that, the denominator exponent. This would be 21, that would be 12. So this would look like x to the 21 over x to the 12, which we would then subtract the exponents. 21 minus 12 is going to give you 9. Or we could subtract the exponents first, which would give us x to the 3 to the 3, and then do the power to a power, which would result in the same x to the 9th power. Okay, to sum it all up, we'll have to remember that like bases being divided, you subtract the exponents. X to the a over x to the b becomes x to the a minus b, a minus b. Or if you do x to the a divided by x to the b, whether it be written as a fraction like this or with a division symbol like this, you still subtract those exponents to get a minus b like that.